I'm Steve Kaufman, and I work at Khan Academy. And today, I'd like to tell you how Khan Academy is saving both time and money by transitioning from Python to Go. First, what is Khan Academy? At Khan Academy, we believe it doesn't matter where you start. What matters is where you go. By offering a free, world-class education for anyone, anywhere, we're leveling the playing field, one learner at a time. Just last year, millions of people spent 8.7 billion minutes actively learning at Khan Academy. Now, who am I, if you'll pardon the brief digression? I've been a software engineer for 20 years, and I've worked at Khan Academy for the past year. In my career, I've found that I've grown the most professionally when I work with people with diverse experiences. I love the diversity of experience that I have seen at Khan, and I'm proud that Khan is committed to further increasing that diversity. One other thing I love about Khan is on the anniversary of our first day, it's a tradition for us to give back. This year, I collected information on all the best remote home office setups for all those who are newly working from home. I always enjoy this kind of quirky, personal gifts that we give to show our appreciation to one another. And now I want to show you how Khan Academy engineers are shepherding us through a remarkable transformation, which will hopefully be invisible externally, just to show how much I appreciate the work of the rest of the organization. First, where did we start? We started on GCP App Engine. And we started with a Python 2 monolith. And this served us well for much of the company's history. Where are we going? Well, we're going to GCP App Engine still. But we're also going to multiple Go services, 27. And we're going to use GraphQL in between the services. So, as you may have heard, there's been an end-of-life announcement for Python 2. And when that came out, it forced us to make some choices. We chose Go. It was fast, which translates to cheaper. It's got a rich ecosystem and a rich standard library. It's simple and productive, and maintaining someone else's code is a pleasure in Golang. I've maintained code and I've written my own code in many different languages over my career. I love the expressivity of writing code. I love doing some clever little trick and doing all these other kinds of things, switching from one paradigm to another, experimenting with things and playing with them. It's a true joy. But the problem is that when I'm maintaining somebody else's code, the cleverness that they put into their code sometimes makes my head hurt. Sometimes I look at their code and I have no idea what this is doing and what the context of the original decision was, especially as it's shifted over time. People switch from one paradigm to another, back and forth. When I maintain somebody else's code in Golang, it's a pleasure because it looks just like my code. I love that. It may be grumpy at first, but I really love the maintainability of Go. It's so simple, it's so easy for anybody to jump into a code base and makes perfect sense to them. We also had to choose what platform we should run on. We chose App Engine, again. We wanted to avoid undifferentiated heavy lifting. Many organizations get a little too caught up in their own creations, and their own sort of creations end up owning them, as they have to have a burden for maintaining something unique that the rest of the ecosystem doesn't know anything about. If there are common problems with common solutions, it's easier for us to focus on our own business value than to try to actually have to make some other unique solution. The other thing about App Engine is that it scales great. When COVID-19 forced school closures across the world, we really had almost nothing to talk about because everything just scaled pretty much amazingly. We had a few secondary systems that weren't user visible that we had to make some tweaks to, but no real problems to speak of, which I think speaks volumes to the reliability of App Engine. I should actually say even more about that. Our PagerDuty is all volunteer. And the reason why we can choose to let everybody opt out of that and have to opt in is because it goes off so rarely after hours. It has only gone off, it's less than once a month for the past year and a half. And it's continuing to go off increasingly rarely in the off hours. And every time it has gone off, it's been our fault. It's not been Google's. So, App Engine's pretty great. I highly recommend it. The other choice we had was, should we stick with the monolith or switch to services? We chose services. Try to imagine an entire family, all living, working, and going to school in the same small living space. I know, it's so far-fetched, but bear with me. We have 86 engineers at Khan Academy, and in our monolith, it started to feel similarly cramped. Borderless engineering required intense thoughtfulness, discipline, and coordination to avoid bumping into one another. Our deploy queues got longer and longer, as we needed to test all the things for even a small change. We also couldn't isolate how much specific efforts cost compared to the benefit they brought, to know whether we were spending our resources wisely, or whether we should choose another path. We also needed to choose how should services communicate between one another. We chose GraphQL for this. We had great success previously with React and GraphQL on the front end. App Engine, as awesome as it is, unfortunately does not support HTTP2 gRPC yet. But GraphQL provided a ubiquitous language across Go and JavaScript divide and across the back-end front-end divide, so that all of our engineers could actually have a very similar experience when they were at least talking about those contracts. Speaking of those contracts, by having our GraphQL be schema-driven and then generate the code from those schemas, we didn't have to get tangled up in expensive contract testing, because we knew that those were exactly what we had written. We wrote the spec first as the contract, and then the code just got generated from that. We also had to decide, how should we divide up into services from our monolith? It's a little messy to put them all in here, but I wanted to illustrate the point that we chose not to make our services very micro-sized. Wherever there seemed to be a good conceptual or technical seam, that's where we drew a line. A few are not directly user-facing. For instance, we have an email service. That's not pictured here. But some, like the static asset requests, go through Fastly and then straight to Google Cloud Storage. What have we learned when we transitioned to Go? And how did we learn those things? So, a lot of our developers, most of our developers, were not familiar with Go in the beginning. So we collaborated and created a tiny little command line app that was all test-driven. And then we deleted all the code, leaving only the tests. We had developers who had never seen Go before be able to actually, one by one, enable the tests and make them pass, and move on until they had a fully functional application that would forecast the weather. Not exactly trivial, but not exactly complicated. It was enough to give them a taste for the language, and it was enough that they, in true Khan style, were able to take those and try to get hints and get if they had any sort of issues, and it would actually work out pretty well. We also had encouraged our developers to read and to practice using Learn Go with tests, which is an excellent resource. After that, we engaged with Arden Labs to have them provide training on site to our engineers and remote for all those people who are remote. One of the big lessons that we learned is to create a cookbook for everything that's confusing. When somebody asks the same question more than once, to listen to that as a signal. And we've written how to do different things in Go, how to do different things in GraphQL, how to translate certain paradigms from Python into Go, and we maintain that over time. Whenever somebody is new, they are the most valuable resource in looking at that, because any confusion that they find, that's a signal that we use to help to improve that resource and make that a living resource as we move on. The other thing that we're doing is we're actually open sourcing some of our ongoing onboarding. We have an open source repository, the Web Workshop, that we're trying to develop in order to allow ongoing education for any new developer that comes on to be able to come up to speed reasonably quickly. When you're making a drastic shift such as from a Python service to a Go service, or from a monolith to services, you need to make sure that that transition can happen in a safe manner. The way that that has traditionally been done is using a technique such as traffic shadowing, where requests go to the new version and the old version, but only the response from the old version is given to end users. And you only compare those, and once you feel confident, then you can shift over to being able to provide the end user with the response from the new version. GitHub pioneered a similar technique using the library Scientist to be able to make those sorts of transitions inside of a code base. That same technique has been ported to many other languages and other frameworks. We were inspired by that, but we at Khan Academy chose to do side-by-side testing, where we're using GraphQL Federation to allow us to transition at the granularity of even a single field at a time within of our GraphQL. So this is what our side-by-side transition looks like at Khan. We develop in the Python monolith first. We make sure that we're actually using the GraphQL endpoint and not taking advantage of the fact that we're in the Python monolith to make a library call. Then we start to develop a Go service. After we deploy that Go service, we end up actually making a request that goes both to Python and to Go. But the Python response is the only one that goes back to the end user. The Go is secondary here, and its response is only used to record discrepancies, and then it's discarded. After we're confident that that has no more discrepancies in it, we then make Go primary, and its response is the one that the end user sees. Python's response is now discarded, and then we transition to Go only and delete the Python code. So in our side-by-side, we start out with the Python monolith, then we develop in a Go service, then we have Python as primary, where Go's responses are secondary and discarded, only used for comparison's sake, to warn us if there's a discrepancy. Then we switch to having Go be primary, and Python as secondary, where the Python's responses are now the ones that are discarded. Then we can delete the Python code and have Go only serving this. It's code time. So the GraphQL schema that we end up changing, here we have this created date field that's already defined in Python. And we'll hit an error if we try to also define it in the assignments Go service. But until we define this field, we can't generate a GQLGen model or write any tests. To get around this issue, we add the migrate directive to our field with the state set to manual. This will allow assignment service to define the created date, but will hide the field from the normal schema. If an end user requests this field, the gateway will continue to fetch it from Python, but will not make any requests for it from Go. Once the implementation of this field is done, we can enable side-by-side testing by setting the migrate directive state to side-by-side. Here, now, both Python and Go are getting the request for that field. When they are both providing it, every request will be examined for differences, both locally and in production. A developer locally will receive instant feedback that there's a discrepancy as they go through either unit tests, integration tests, or just click around on the site locally. In production, we can see over millions of requests if there are corner cases where the fields might differ. Remembering to first make a Python set deterministically ordered is probably our most common mistake, even if it's not really apparent to a user. In production, we can also look for patterns in the discrepancies in many ways. In case there's an edge case that, for instance, only occurs at a particular time of day. I'm not going to go through all the different ways that our SREs are able to slice and dice this to identify unusual patterns, but just suffice it to say that we have a lot of great metrics, and they bring that to the developer's attention. So now our schema changes, and we can now ignore the Python value of the field and pass the one from Go. We support this state to make it easier to stage deploys and to reduce the risk of rollbacks. We also use this state as we are transitioning to having all the GraphQL traffic move through the gateway. It may be that some clients, mobile native for example, may not yet be able to query through the gateway, and so we may need to keep a field defined in Python to satisfy those requests. Once we're happy with the Go service serving traffic for this field in production, we can remove the definition and the related code from Python. Once we do that step, we can remove the migrate directive entirely. This field is now just a normal GraphQL field, like any other. So, now engineers are happy and productive in Go, our efficiency went up, our costs are bending down. What's next? Right now, we have 34.5% of production traffic served by Go. And as we kind of expected, it's been sort of following a normal curve. And right now, we're seeing an acceleration in the code that's being transitioned to be solely served by Go. We've also adopted a new policy where we're trying to share as much as we can open source by default. Before, we were much more concerned with only putting out open source code that we were committed to maintaining. But we realized that there's a missed opportunity. Sometimes the community could benefit from some of the choices that we've made without necessarily having us to devote a large percentage of our engineering staff to be able to maintain that to meet all the possible end user use cases. We're still open to collaborating, but we might not, in all cases, pursue all the different use cases that the community is interested in. We're also going to try to share our onboarding process. We're developing some of our individual tools, like the Web Workshop and the Forecast app, as open source. And we hope that as we onboard new developers who are unfamiliar with Go or our environment, that will be beneficial to them as well as other members of the community. So, I hope that this was useful to you, and I hope that you found this story to be compelling. I certainly can highly recommend Khan Academy as an excellent place to work. And if you're in the market, feel free to drop us a line. Thanks. Any questions?